All right, hello everybody. My name is Garshaw Amidi-Abraham. This is my first Texas Groundwater Summit, so I feel very honored to be here right now. First time in San Antonio as well. I'm coming from Oregon, so I'm trying to get used to the heat. So my name is Garshaw Amidi-Abraham. I'm Senior Specialist with OpenET, Inc. So OpenET uses best available science to provide easily accessible satellite-based estimates of evapotranspiration for improved water management across the western U.S. OpenET is an online water data platform. It's a consortium, and now it's a new nonprofit that's been under development for the past 5 years by scientists, water experts, and practitioners from about a dozen different universities and organizations. So here's the obligatory drought slide. Over the past couple decades, we've seen persistent drought in the western U.S. And over the past couple years, we've seen a spike in exceptional drought, so much so that we are seeing and making interesting dinosaur discoveries here in Texas and other archaeological discoveries around the world from dried up riverbeds. So I suppose that's the only upshot of this drought period that we're in right now. And like the state of California, Texas is episodic. So it deals with extreme flood events at the same time, or the threat of extreme flood events at the same time that it deals with the threat of drought. But focusing on drought, our farmers they face challenges, and they face challenges to put food on our plates. Some states are dealing with cuts of up to 100% of surface water, and so farmers are faced with the challenge of growing the same amount of food with a fraction of the water. Water managers are similarly trying to balance the needs of farmers, people, and wildlife. And so farmers and water managers at the same time are facing these challenges oftentimes without having access to a very important piece of data, which is consistent and timely data for the amount of water that crops actually consume throughout their growth cycle. This data is oftentimes expensive and fragmented. So OpenET fills this huge data gap in water management. So the ET in OpenET stands for evapotranspiration. Evapotranspiration, is the second largest component of the water cycle, and it can be thought of as the opposite of precipitation. It's the process by which water evaporates from the land surface and transpires from plants. And as such, it's the measure of water that can no longer be used in a local system after being applied to the landscape. So this is sort of not the same as water that would be recharging into a groundwater basin or running off to a local stream and river, because that water can be reused. Evapotranspiration cannot be reused and leaves the local system. And I apologize if most of you probably know this already. I'm just making sure that we're all on the same page so we can have a good discussion about it. Evapotranspiration is happening all around us all the time, but because water returns to the atmosphere as water vapor, it's invisible, and that makes it difficult, accurate, and expensive to measure using ground-based instrumentation over a large area. Luckily, over the past 25 years, scientists have developed techniques to calculate and map evapotranspiration at the scale of individual fields using publicly available satellite and weather data. So OpenET uses satellite observations from Landsat, which is a joint USGS-NASA satellite, and it also uses data from other European Space Agency satellites, but mostly Landsat. And so the way it works is this. As anybody who has run through a sprinkler on a hot summer day knows, evaporation consumes energy and cools the surface from which it's evaporating from. So after you run through that sprinkler, that water will evaporate and cool your skin off. And the same thing is happening all over the Earth's surface. And this cooling effect is visible to Landsat's thermal infrared sensor, which detects higher rates of evapotranspiration as lower land surface temperatures. So in other words, cooler temperatures that those thermal infrared sensors detect mean that more water is being used or transpired by plants and evaporated from the land surface. So combining this satellite data with gridded meteorological data allows scientists to accurately calculate evapotranspiration for every single pixel in a satellite image. So OpenET provides field-scale data. In each pixel in the satellite image is 30 by 30 meters, or approximately a quarter of an acre, which enables us to calculate evapotranspiration for most ag fields across the western U.S. And this resolution also allows us to measure the effects of drought or wildfire across the landscape with pretty good precision. And so a big strength of OpenET is its collaborative nature and its collaborative beginnings. The technical team includes over 30 researchers and practitioners from NASA, Desert Research Institute, U.S. Department of Agriculture, U.S. Geological Survey, University of Nebraska, University of Wisconsin, University of Maryland, Cal State University, Monterey Bay, Google Earth Engine, and the web development firm Habitat 7. All these folks are experts in satellite-based estimates of evapotranspiration. They're experts in cloud computing, software development, and user-driven web design. I'd also like to note that the Texas Water Development Board was also involved in the early development stages of OpenET, and we thank them for that. And one of the reasons that we pulled together such a big team was basically to get agreement on the numbers. We wanted to tackle the issue of conflicting and competing numbers out there for evapotranspiration. So we wanted to bring these commonly utilized approaches together and these scientists together, basically to agree on the numbers and create confidence in practitioners that are actually using this data on the ground. So as shown in this diagram, some of the water that falls as rain or snow is applied to irrigated fields, and that water may recharge a groundwater basin or run off to a local farm, and that water can be used again. In the red boxes, evapotranspiration cannot be reused. And in arid regions, we pay very close attention and special attention to precipitation, which is the largest component of the water cycle, to get a sense of how much water will be available. But it's also critically important to understand how much water is being consumed, which is measured through evapotranspiration. So managing water without evapotranspiration would be like trying to manage a household budget without knowing how much money you're spending day to day. So now we can talk about specifically how OpenET can help. OpenET can help rural communities design locally driven water conservation and trading programs. Local groundwater managers develop more accurate water budgets, incentive programs, and other innovative strategies. Policymakers to accurately track water supplies and co-develop solutions with local communities, and farmers to improve their irrigation practices to maximize their crop per drop and reduce costs for fertilizer, water, and energy. A couple examples of OpenET uptake, and these are just a few of the many use cases we have. In California, this evapotranspiration data is being made available to groundwater sustainability agencies to locally manage groundwater, and it's also being integrated into water accounting platforms, which are being piloted in a couple different regions throughout the state. In Oregon, they're legislature passed a bill that required their Department of Water Resources, Oregon Department of Water Resources, to develop budgets, water budgets for every single groundwater basin in the state. So OpenET is being used to help develop these groundwater budgets. It's also being used to support a more local conservation program in the Harney Basin, which I'll get into in a minute. And in Nebraska, OpenET is being integrated alongside a groundwater evaluation toolbox, which is sort of a one-stop shop for groundwater modeling. And both of these are being integrated into Twin Platte Natural Resource District's water data program. So we're going to play a clip about a video clip on OpenET's use in water accounting and trading. This video is featuring Eric Averett, who's the former general manager of Rosedale or Rio Bravo Water Storage District. This is in the very southern, this is in Kern County, which is southern San Joaquin Valley in California's Central Valley.
Rosedale is located in Kern County. It's one of a number of water districts that provides both agricultural as well as urban water supplies. Kern County is considered ground zero in the context of the Sustainable Groundwater Management Act. We have a significant amount of overdraft which challenges the water supply reliability for the region. The OpenET data set that we will be using is the basis of our water budget for Rosedale, which will be reported to the state to show compliance with the Sustainable Groundwater Management Act. For the landowner, it's very, very important because they have now a responsibility to live within their water budget. OpenET has been a very, very effective tool, giving us near real-time information to evaluate the water budget information for every parcel within Rosedale. Landowners can make decisions as to whether or not they're going to irrigate again, whether or not they're going to enter the market as a buyer or a seller. And again, it's really information to make informed decisions, but more importantly, to manage the resource on their own behalf.
So going back to Oregon, as I mentioned before, statewide, OpenET is being used to help calculate water budgets. In the Harney Basin, it's being used to help implement a local water conservation program. The Harney Basin in Oregon is critically overdrafted. In total, they pump about 100,000 acre feet more than is recharged. And in some areas, the groundwater table is dropping around 8 feet per year. So OpenET is being used in a state and federally funded program that's providing payouts to farmers that are voluntarily cutting their water use. OpenET is being used to track water use in this case. And it's also being used alongside a water user reporting program. It's being used in conjunction with meter data. Here's another clip from Oregon. OpenET is helping alfalfa farmer and state rep Mark Owens save money.
We're under a drought in most of the West contiguously. The climate is changing. Summers are getting longer, it's getting hotter, it's getting drier, we're getting less precipitation. So I think there's a growing awareness in all of the West that we have to use significantly less water. So agriculture has to figure out how to get as much per drop of water as they can. I started to try to understand evapotranspiration when we collectively started trying to figure out, can I put less water on my fields and still yield the same amount or more? I go online and I can pull up the evapotranspiration numbers. I compare the amount of water that I apply daily, weekly, probably monthly, compared to what OpenET says, and I can see if I'm over-applying or under-applying. So if I put on more water than evapotranspiration I already have in my bank, I can shut off for a couple days. That means we could use about 25% less water and still produce the same amount of crop, which means a lot if you're putting out several million gallons of water a day.
So we don't have any current major use cases in rangeland management, and right now we're looking for folks to work with in this particular application. But Some potential ideas, and we'd love to hear from you folks on this. Identify ET signal from various rangeland practices, which might include riparian fencing, cheatgrass management, stream restoration, and rotational grazing. Develop basin-wide water budgets in rangeland watersheds for both wet and dry years that might inform adaptive management practices. And also integrate remotely sensed ET estimates with higher resolution drone and field data to expedite labor-intensive evaluations. And here's our last video.
My name is Paul Bruchet. I'm a rancher just outside of Kremlin, Colorado. We run a cow-calf operation, raise hay, irrigate out of 3 different water resources. We also operate a guided fly fishing business to help supplement income and work the ranch as a family. Water to our operation means everything. We rolled through the drought of the early 2000s in the headwaters, learned some lessons there, which is largely why my family and my neighbors are as engaged as we are with water. We are truth testing different forms of measuring water used for irrigation on high altitude perennials. We are studying the recovery of those crops after having different forms of treatment to them, the full season curtailment, and then a split season where the producer was allowed to irrigate until June 15th and then required to shut off for the remainder of the season. I'm excited to continue to learn about the information and data gathered by OpenET. I'm excited to truth test that against many of the other forms and mechanisms that we have working. With OpenET, it completely changes our ability to understand what's going on within our fields. Water is the lifeblood of the West, and we have to figure out how to do more or the same with less. The more that we have the science and the data, the more that we'll be able to make good decisions.
All right, I'm running out of time here, so I'm going to get through these last slides really quickly. So OpenET leverages Google Earth Engine and cloud computing to store and process data, run models, and make it widely available in a user-friendly way. You can access OpenET through the Data Explorer on openetdata.org. Anybody can create an account and start using OpenET. It can also be accessed through the application programming interface. And this data, you can make custom calls and using Python, and you don't need to know that much Python, and there's incredible documentation that our team has developed. And finally, it can be used or accessed as a Google Earth Engine asset. And so it's being integrated into other applications like irrigation management software and groundwater accounting tools, like I mentioned earlier. None of this would be possible without our API, which allows the inner workings and the data of OpenET to talk to other software applications and end users. So dedicated to transparency and equal data access. For this slide, I'll just say that OpenET conducted one of the largest, most rigorous intercomparison efforts to date, which basically included comparing the satellite-based ET data to ground-based measurements of evapotranspiration over 140 flux tower sites all over the western U.S. And these flux tower sites were in various ecoregions and various crop types, so they represent a relatively robust assessment and variability of accuracy. We've gotten some good media hits ever since launch in last October. Over 400 media outlets locally and 60 international as well. And coming up next, we're launching our public API, publicly available API, the next couple months. We're creating a layer for effective precipitation, which is critical for getting to volume of applied water from the ET data. Custom reporting tools, which makes it very easy to report and put on different filters and create a report how you want to. Addition of daily data, which is very important for irrigation management. ET forecasting, using algorithms that I really don't understand, but somehow they work. and finally geographical expansion to the rest of the lower 48 states and eventually internationally. And with that, I'd like to thank you for your time today, and I am happy to take any questions if we have time. Yeah, I'll be here until Thursday morning, and my contact information is right on the slide. So, thank you so much.